Hi there, welcome to Machine Bytes, your go to place to learn AI the smart way. In recent videos, we learned about overview of AI and then different kinds of ML algorithms. In today's video, we will try to summarize what all challenges one can face while working with machine learning algorithms. Before starting with that, let's revise how end-to-end ML flow looks like. In general, when you start with you have some data, then a model is trained over that data. And if we are satisfied with the accuracy of that particular model, in that case, it is deployed into production. Or if we are not satisfied, then we again go to the modeling part. This is how the entire process looks like. So, during all these steps, there are different challenges that one may face. Let's explore those one by one. Since the first thing that is required is data, so first challenge is with respect to data only, that is data collection. To train a ML model, we need huge amount of data, and that is a tricky part. Data collection can be done from different sources. Maybe we can ask for the data from the domain experts or industries from that domain. Otherwise, we can fetch the data using APIs or web scraping can be done. The second challenge that one may face is with respect to data again, which is insufficient quantity of data. If we have two models, say one is model 1, which is a simple model, and we have model 2, which is kind of complex one. Now, if model 1 is given 100 data points and model 2 is given 1000 data points, surely model 2 will perform better than model 1. But it could be the case that if both the models are given same number of data points, then model 1 may perform better than model 2. And in that case, computational cost will be less because this model is comparatively simple. That's how number of data points that are provided for training makes a huge difference in the training process of model. There is a famous paper around this, which is the unreasonable effectiveness of data. This paper tells us that even simple models may do wonders if the right amount of data is given to them. The other challenge is non-representative data. Biasing is the main cause of non-representative data. How this happens is when the samples are collected for training data, we were biased towards some class, and that creates imbalance in the data. For example, if you are conducting one survey to find out if board exams this year were easy or not. So, while conducting the survey, if you have taken the votes from the students of a particular region only, then your data will be biased. Now, it could be the case that in that particular region, either teaching facilities are good, average, or poor. So, our most of the data will be aligned with these conditions only. We will not have an overall view of the board exam's toughness. There is a famous example of this. In 1936, there was a survey conducted for US presidential elections, which was done by Literary Digest. So, in this survey, they were confident enough that London will be winning that election. But when the results came out, Roosevelt won that election by 62% votes, which is a huge number. Later, it was found out that the addresses of people collected to conduct this survey were taken majorly from club memberships or mart memberships, magazine memberships, etc. So these were the comparatively richer class of the society. voted for London at that moment. And out of the total number of people who were reached out for this survey, only 25% of people responded back with their vote. It means other 75% of people were either not interested or were inclined towards the Roosevelt. This is how sampling bias happen in the field of machine learning as well. To reduce the sampling bias, we should be considerate enough to collect the data for all the classes. The next challenge in the field of machine learning is poor quality data. Sometimes we might have huge amount of data, but having a very poor quality. What we mean by poor quality is noise, errors, outliers, etc. When we have all these things in our data, the resultant model will also perform poorly. To overcome this problem, all these data points should be analyzed and rectified before passing to the model as training data. The other challenge is irrelevant features. Sometimes we might have some features which will not make any contribution to predict the target variable. Such features are irrelevant to data and makes the model performance poor. Say if we are trying to predict the marks of students for their board exams, then we might have different kind of features like number of study hours, marks in previous classes, and others. But if we have feature like hobbies, now hobbies might not be relevant to the total number of marks that a particular student will obtain in final marks. But having that feature in our training data may lead to poor performance of the model. Due to this feature, our model may learn some patterns which do not exist in the real life. The other challenge that is faced during machine learning problems is overfitting of data. Sometimes we choose an algorithm so complex that it memorizes the data by heart. For example, if this is the data, then our model may memorize it like this, trying to touch every point. However, a general model should have line something like this. In such cases, our model will have very good performance on training data, but on testing data, it will fail to have satisfactory accuracy because it has memorized the pattern which do not exist in real life. Overcome this problem, we should simplify our model, collect more data, reduce noise, and then train model. Next challenge is underfitting. Underfitting is when a model performs poorly on both training and testing data. When does this happen is when our model is too simple to learn the patterns in the data. For example, if this is our data and our linear regression line is something like this, so it will perform poorly on both this training data and unseen testing data. To overcome this issue, one can select some more powerful model. We can feed better features and reduce the constraints of model like regularization and hyperparameters. The next challenge is to choose right algorithm. There is a famous theorem called no free lunch theorem. You can check that. It states that however complex or powerful an algorithm is, you can't guarantee that it will be the best model or algorithm for a particular problem. So if you say model XYZ is the most powerful we have in market, but still you can't say that it will be the most impactful for some particular problem. Overcome this problem, one first needs to shortlist the algorithms on the basis of their mathematical background and patterns in the data. Then, out of these shortlisted algorithms, we need to train our model using all these algorithms and then choose the best one. Next challenge comes under the step of integration and deployment. ML algorithms are part of software applications only. We need to integrate them well for better performance and then deploy to the production environment. After deployment, we also need to consider the retraining of ML algorithms on the new data points. For that, we have two kind of methods. One is offline or batch learning, and the second is online learning. The major challenge with machine learning algorithms is cost. All the steps and challenges that we discussed so far incur a lot of cost to the organizations. See that if we go one by one, data collection is a very costly step, and then adding labels to unlabeled data is also a laborious process. High computational power is required to train ML algorithms. Deployment, retraining is also a very costly process. Maintaining, training, and making predictions using a lot of data is also harmful to the environment. There are numerous studies around there which shows us how much AI is impacting the environment. So these were the common challenges that are faced during the end-to-end flow of machine learning problems. That's all for this video. Thank you so much. Take care.